So good day guys, welcome to today's lesson. In today's lesson, we are going to be designing the slab by finite element method. Okay, so now what we need to do is to select all the floors, select object types and select floors. Okay, select it, close. Now since in the post-processing we've checked the deflection and we can see that most of the deflection has passed. That means they do not exceed the 20 millimeter or the span over 360 under live load condition. Okay, but now we want to do the ultimate, which is going to be the factored load. So right click, show selected objects only. Now since most floors are typical, let's just design the 15th floor. But if they are not typical, you just highlight it and select the floors you want to design. So this is where I can just highlight it again, come to this point, concrete slab design, right click, view preferences. Now I'm using Eurocode. You can see the design code here, design code, but I want to change it to the UK national annex. Now you can see the typical you can see the typical Eurocode. It has an alpha cc of 1, but the UK national annex has an alpha cc of 0.8. So that's one of the major difference between it. So minimum cover, for example, I want to change my cover to 25 mm for my slab, 25 mm. Preferred bar size, I want to use 12. Then if I'm doing strip, it will come to layer B, which will do that in the next video. But today's video is going to be on finite element. Okay, so PT stress check. So there is no post tension in this. I will ignore this and click OK. So I've done the preferences for my slab. Come back here, design for flexure. So I'll come to finite element base and choose the type of rebar I want, and I can change the concrete cover I want. Okay, so specified center, but I want to use it from preference, the one I did initially. So I can ignore PT when designing this slab. That's if I have applied it, but I'll click OK. So we are done with that. Next thing I want to do now is select design combination. So for my slab, let's say I just want to use 1.35 GK plus 1.5 QK. I'll just come here, and I know that is mostly on DS2. Anything with S2, that is it, because I know that from checking all that. You can see the contour 2 is the same, so I'll use this and select design combination and click OK. Or let's see what the show is about. Okay, let me select this combination and show. So you can select the one I want. So this is this one, show dead plus live. That is what we use for it. But since you've assumed your slab as diaphragm, I can advise you to still bring everything in. Okay, let me remove this envelope. So I'll remove the service envelope we created. Service envelope. Okay, select it, bring it out. Then the ultimate envelope, so select it and bring it out. So once you put your mouse on it, it tells you what they are. So 1 plus 1 super dead and everything. Okay, so click OK. So we've done with the load combination we want to use. Now next thing I'll do is select story for design. So I said all of them are typical, so I can design the 15th floor and click OK. That's the one I want to do. So let's see it, select it. It has been selected. If you want to select all, you can select all, but I just want to use 15th floor alone. So select it. Now you can start design or click this. So click concrete slab and it will be run. Okay, so let's give it a little while. Now it has brought us our finite element result. You can see your contours. So for us to be able to understand it, going in this direction, the direction along this direction my mouse is, that is 1 or X direction, and going in this direction like this is 2 direction or Y direction. So let's come back here, display flexure design. Now we can see this is what we have. So generally what I do is come to this and pick, let's say I'm using 12 and I'm using 12 for the top and bottom. Now my spacing, let me try 200 for the top and 225 for the bottom. So let's click apply. Now, but because this is direction 1, I told you direction 1 is going in this direction. So you can see what we have. So you can see, look at the contour down here. Okay, look at it. So anywhere, the problem we have here is that this is at the center of the column, and the center of the column is very stiff. It can't deflect. The column cannot deflect because it's a thick 3-meter column, so 3-meter won't deflect. So that's why it's very stiff and you require more reinforcement. But practically, let me show all objects. Practically, what we do is we take it a little bit at the face of the concrete column. So what I have here is 329, so we require more at this point. So that is generally what we require. But me, practically, I can ignore this because from year to year is about maybe 300 or 500, so it's still very ignorable. It will be able to redistribute back to itself. So this is for the top rebar. Now let's see what for the bottom rebar. Apply. So we can see for the bottom rebar what we've provided, 12 at 225 is very sufficient. Then let's see in direction 2, this direction like this. Apply. So you can see what we have. Then bottom direction. Apply. So with this provision we've done, it is sufficient enough. But you can see we have an option for impose minimum reinforcing. So let me show you what they are before I select minimum. Let's look at top rebar now. So it has given you a contour. So where you see purple, they reinforce. Look at it at this corner there. It is E plus 10, E plus 3. That is 10. Whatever you get times 1000. So the purple you need 0. Let's say we need about 0.6. Once you put your mouse on it, it will give you the value. So it's telling me that now for the top rebar, direction 1, top rebar, I don't need anything here. I don't need, see what I need, maybe 43 millimeter here, 40 something millimeter for this here. It's only when I get to the support I need large reinforcement. But see what will happen when I tick this impose minimum reinforcing now. So you can see what I need now. I need, this is the minimum I need by every code. So you notice that at this point we need bottom reinforcement, at this point we need top reinforcement, now at this point here too we need top reinforcement because the span is very small. So when we have sagging, hugging, we still have hugging at the mid span, hugging at the support, sagging, and so on. So this is direction 1. Now let's see what without impose minimum and direction 1 bottom rebar, let's see what it is. So you can see now I need about 411 around here. Just look at this, what we have here. Look at what we have. So this is it. Now let me see what will happen if I impose minimum reinforcing. So you can see if I impose minimum reinforcing, I still need to put nominal more at the bottom here, even though it is at the top again. I still need to place here. Same with this, same with this. So that's just the concept of this. So we've seen that we can look at it here, 12 at 200, apply. Let's see if it suffices with the minimum reinforcing. Yes, it suffices with the minimum reinforcing. So we are these are just very nominal. They are, most times we ignore it because if I want to go into the joint, I'm going to put unlimited amount of reinforcement at the support inside that center point because it's very stiff. So let's look at this now. We have direction 1 bottom rebar, we need 0 here, but let's see the top rebar. Let's see what to provide for us. So okay, so 12 at 200 is sufficient, or I can put it now and just see what I need. Okay, so see the red one, I need 200 and this for this. Okay, same with these 227. So that's just the concept of finite elements. Okay, so we are done with that. In the next video we'll be talking about strip. So thank you for watching today's video. If you have any question, you can drop it in the comment section. Thank you very much.